Question number 2. An engineer designs an electric heater to melt ice from the rear window of a car. Okay, the heater consists of a single thin metal wire made from a high resistance alloy. Okay, so you have a single thin metal wire. The horizontal parts of the wire are 0.6 meters long and are separated by a vertical distance of 0.03 meters. See, this is the heater wire. So it starts from here, 0.6 meters long and 0.03 meters. So like this, now you see one length here, one width here, one length here, one width here. And like this they have kept it in a zigzag manner. Okay, the heater is designed for a 12 volt supply. Voltage is given, power is also given, 150 watt. Then calculate the resistance of the heater when it is at its working temperature. What is the resistance of the heater? Resistance of the heater, say, since V is given to you, what's the value of V? Let me write down the value of V. V value is given as 12 volt and P value is given as 150 watt. So you can find out the value of R, which is given by V square by R is equal to P. Let me write down the formula first. P is equal to V square by R. Or you can get the value of R from here. R equal to V square divided by P. Substitute this. It becomes 12 square divided by 150, which is equal to 144 divided by 150. Let us find what is the value over here. So this will become 144 divided by 150 will be 0.96. Thus the answer here is 0.96 ohms. Okay. Then next, the resistivity high resistance alloy is given. So this is the resistivity. Calculate the radius of the wire. What is the radius of the wire? So how do we do? When resistivity is given, the direct formula is R equal to rho into L divided by A. Rho is already given area. What is the area here? So rho L is the length of the wire and area is nothing but pi R square. Okay, if all the values are plugged in, you can easily get the value. So now pi R square, let us use this as a subject. R square should be equal to rho L divided by pi R. What did I do? I pushed this one outside and pulled this R inside. So I got this value here. And thus your value of R should be equal to square root of rho L divided by pi R. Right? R you just calculated over here. This is your R. Pi is a constant. Rho is given to you. L you need to find. What is the length of the wire? Now let me go back to this. Now you see, length of the wire is not just 0.6 meters. See, because you see, if you extend this length, what is the total length? That's what you need to take. So therefore, this is L time L. This is 0.6, 0.6, 0.6, 0.6, right? I need to add all the lengths here. 1, 2, 3, 4, again 5 over here, 6 here, 7 here, 8 here. So 8 times 0.6, 8 times 0.6 plus. See, we forgot to add this bends over here. See, this bend is also counting, right? So, one bend which is 0.03, second bend, third bend, fourth bend, fifth bend, sixth bend and seventh bend. So, there are totally 7 bends over here. So, which will give you 7 multiplied by 0.03, right? I have now compensated for all the lengths over here. I have taken this plus this plus this plus this and so on. So, I got this value. How much will this be? 8 into 0.6 would be 4.8. 7 into 0.03 would be 0.73721, 0.21. So totally it comes out to be 5.01. What is the unit? Meters. Nearly 5 meters. Okay, so therefore, now let us substitute all the values over here. I will now write this small r. I'm sorry, this is small r is equal to square root of rho is 1.5 into 10 to the power of minus 6. L is 5 meters divided by what is this pi? 3.14 multiplied by capital R. What is capital R? 0.96. 0.96. Let us substitute all this in your calculator and get the answer. So therefore, this should be 1.5 star 5 is equal to so much divided by 3.14 is equal to so much divided by 0.96 is equal to so much. Okay, I have not taken the powers. So I will take the powers. 10 power minus 6 whole to root is 10 power minus 3. So I will write this into 10 power minus 3. What is the answer we got? We got the answer as 2.488. We took the square root, right? No, we haven't taken the square. We need to take that value. So take the square root of this value. I get 1.577. So 1.577. Since I have only 2 significant figures, so I will put this also as 1.577 is close to 1.6 into 10 power minus 3. What is that we are finding? We are finding the radius. Radius should be in meters. So here meters, or I can write this as 1.6 millimeters. This is the answer for it, right? Okay, let us move on to the next one. The heater is used to clean a layer of ice from the window over an area indicated by the dotted line on the diagram. Where is the dotted line? This is a dotted line. So it is something like this. So for example, if I consider this is my wire, this is my wire as you see here, this is my wire over here, and this is ice, okay, and ice is kept on top of it like this over here, okay. So therefore, when the wire gets heated, when electric current is passed through the heater, what can happen? The wire gets heated up, and as a result of it, the ice will now start melting and it will convert into water. Simple idea, right? Okay, instead of taking a hammer, hitting it across and doing all these things, we can do it like this. Okay, now let us read what is that has been given to us. Now what has been asked? The heater is used to clean a layer of ice from the window over an area indicated by dotted line on the diagram. Dotted line is shown here. See, this is the dotted line. This is a dotted line. So it means ice is now completely filled over here, and you are going to keep the heater on above it, right? And then what does it say next? The water has melted immediately. Water that has melted immediately flows away from the heater. Determine the minimum time required to melt ice. So what does this statement tell you? The water that has melted immediately flows away from the heater, which means that whatever heat you are providing, it is useful only in converting the ice to water. It does not raise the temperature of water. That's what it tells you. Okay. So therefore, the energy that you have provided should be useful to melt the ice. So what should you write here? E should be equal to m into L. Do not use mc delta t. It's of no use. Of course, E is not given, but anyway, it's of no use, right? The thickness now, E. What is E here? E is nothing but energy. Okay. Now, energy, where is energy given to you? Energy is not given to you. But what is given? Power is given to you, right? But we already know that energy by time is equal to power, or energy is equal to power multiplied by time. So I can put this here. So I'll get power into time is equal to mass multiplied by the latent heat. What is m here? Mass of ice. Is mass of ice given here? No, mass is not given here. But instead density is given. So you can calculate the mass. How do you calculate mass? Mass is equal to volume into density. Now to find volume, what is that I am looking for volume? So you have an ice block like this. This is your ice block like this. Okay. And then this has a small thickness over here. It's like this. So this is what is being given to you already. Okay. Now what is that you need? You need the thickness T, length L, breadth B. Do I have all these parameters? Let us look at this. So thickness of the layer, ice layer is given 0.5. T is available. What about your L and B over here? That's what we need. Now let me go back to the diagram and see what is happening. So this is the place where you kept the, what you call the entire this one, right? The ice slab. So length is already known. This is your length, right? What is your breadth? This plus this plus this plus this, all this, the total value here, right? 0.03, once, twice, thrice, 4, 5, 6, 7, right? So therefore, your breadth here is nothing but 0.03 multiplied by 7, which should be equal to 0.2 unit meters, right? 0.21 or 0.2 meters. So L equal to 0.6, B equal to 0.2. Now let us take these values. So we will write L is equal to 0.6 meters, B is equal to 0.2 meters, which we have calculated from the earlier part. Okay, now let us substitute over here. So this should be L, length, breadth into height, thickness into rho, which should now be equal to, what is length? 0.6, breadth 0.2, thickness, what is thickness here? Thickness was given here 0.5 millimeters, 0.5 into 10 power minus 3 multiplied by rho, density, what is density? 900 kg, 900 kg per meter cube. When I do all this, let me see how much do I get. I get a value equal to 0.6 star 0.2 star 0.5 star 900. So I get this answer as 54. So I get 54 into 10 power minus 3 into 10 power minus 3. What is this? M in kg. I'll write this kg only over here. Okay, very thin ice layer you have. Now what is that I need? M is known, L is known, T I need to find, right? So this is what we are hooked in already. So therefore T should be equal to ML divided by P. So let us substitute 54 into 10 to the power of minus 3 multiplied by L. What is the value of L? 0.336 into 10 to the power of 6. Mega stands for 10 power 6 divided by power. What is power? Where is the power here? Power. Where is the power here? Where is power here? We have seen this in the previous problem here. Power is seen to be 150 watt. Okay. So let us substitute that also. given by power is nothing but 150 watt. So when I do this, use your calculator, so which you get 54. Okay, let me start. 54 multiplied by 0.336 divided by 150 will give me 0.12. 0.12 into 10 power minus 3, 10 power 6 is nothing but 10 power 3 over here. So let me take the full value, 12096, right? So 1209 would be 121 over here. So 121 seconds. So you got the answers 121 seconds. Okay, next. The battery of the car was almost discharged before turning on the heater. Discuss how this is likely to affect your answer. Before we started the heater, the battery was discharged. What will happen? When the battery is discharged, the internal resistance of the battery increases, right? When the battery's internal resistance increases, what can happen? So some power, some energy is spent on the internal resistance, right? So therefore some amount of energy is lost over there, which means some power is also lost. So when some power is also lost, then what can happen? See, the power available for heating the ice reduces. We already crossed the time. Okay, heating the ice also reduces, which means what? This P is now reducing. Right? Now let me go back to the expression here. The expression says T equal to ml by P. Okay, so T is equal to ml divided by P. See, m, nothing is going to happen because the internal resistance is changing. M is the mass of the ice. Latent heat of ice, property of ice, nothing can change. P is nothing but the power which is being supplied to the ice. When this value reduces, 1 by P increases, which means time taken to melt the ice increases, right? This is the answer that we expect. Okay, see, always in IB you should watch one thing, that if you have one big question, the question will be subdivided into several parts such that the answer what you get for the first part will form as an input for the second one, and the answer to the second one will form as an input to the third one, and somehow each of these questions are very well connected. So you should now answer it also accordingly. Okay, so therefore this question should be answered based keeping in mind this particular question. That's what it says. Discuss how this is likely. So when you use the term discuss over here, you need to elaborate over here. Okay, do not just say, even if you know what is the answer over here, do not just say time taken to melt the ice. You won't get mark over there. You need to discuss it. Then allow 2 reasons why it is important for scientists to research effective solutions for energy storage using battery technology. Why do we need to go for the battery storage, energy storage reasons for the battery technology? The first one, larger the energy storage. What is that you get? Energy storage. Larger the energy storage. What can you do? So you can better cost reduction. So how did I get this idea, if you ask me? See, in this problem, okay, it said that the battery of the car was almost discharged. If it had a much more larger power, larger storage, then automatically you can say that maybe it would have taken some more time for it to discharge. So as a result of it, the internal resistance will not increase. When internal resistance does not increase, time taken to melt the ice will also be reducing. Okay, if it reduces, it means the cost for you is also reducing, right? Because time is money. So as a result of it, cost can reduce. And secondly, larger the energy storage. Now, second, what you can say is, you can also say, whenever you use a battery, okay, there's a possibility that some amount of gases might come out of it, so which can harm the environment. So what you can do is, you can see to it that, okay, the environment does not get spoiled because of this, right? So that's the second reason that you can say. I actually need only 2 reasons. Maybe we can think of this also. Now let us say, for example, if I have a battery which will run for something like 1 month, okay, lead acid battery which will run, let us say, for 1 month. It will have a space of this much big. Okay, if I want to store this electrical energy for something like 5 months over here, then what should I do? I should stack one battery over the other, serial connection. I need to do it. Okay, but if at all, if I have a better technology so that the energy storage has been improved and you can have all of them into a compact one, then what can happen? You can save the space, right? Save the space. So this, you can give all the three reasons and definitely you will get a full mark for this. I hope this is the last question for this. Okay, so let us see the next question. Thank you.